So to begin graphing this inequality, we're going to start with graphing the boundary line. And I'm going to graph the boundary line using my simple my slope and intercept. So my intercept is 3, so I'm going to go up 1, 2, 3 on the y-axis. My slope is 5 over 2, so I'm going to count up 1, 2, 3, 4, 5 as a rise and 2 for the run, put my other point. Could also count that backwards. I could go down 1, 2, 3, 4, 5 and over 1, 2. Just get another point to make a nice line. And I'm going to draw my boundary line like the problem was equal to. But because this is an inequality, I have to decide where more of my solutions are. So then I'm going to test a point in this inequality, and I'm always going to test 0, 0 as long as it's not on the line. So I'm going to plug in 0 for y. I'm going to plug in 0 for x and see whether this inequality is true. 5 halves times 0 is 0, and 0 plus 3 is 3. So then I have to ask myself, is 0 greater than 3? And that's a no. So this tested point is not an answer to my inequality, so I want to shade on the other side of the inequality because I'm shading in solutions. If you want to make sure you're right, you could pick a point over here in your shaded area to see if those are solutions. And then your last decision you need to make is whether you need a dotted line, and you make that decision on whether the points on the line are actually solutions to your inequality. The points are an equals to. This inequality doesn't have an equals to solution, so this line needs to be dashed because you do not want to include the points in the line. You can either make it dashed, or you could actually go through and make little erasers in this line if you wanted to, but just writing the word dashed is fine.